the way through solving a polynomial function, all the way down to all the zeros. Put it all together today. All right, so why would I put in my first step, is it factorable? We just talked about it.
Oh.
So, it's the easiest way. Could I factor this?
Yeah. No.
I couldn't?
You could. You could do this.
You do the two parentheses, or you could put it in a box. Right? So couldn't I do, I'm going to do the box. Because you know what? The box, when things are jumbled up in here and you can't tell whether it's factorable, the box works the best. That's what I'm going to do. So I'm going to put this into an area model. And I'm going to say to myself, x cubed negative 6x squared 10x and negative 8. Is this factorable? Well, these two have an x squared. This one has an x. This one has a negative 6. These two, right, x squared times negative 6 makes negative 6x squared. These two have a 2, right? 2 times x, that doesn't work. Correct? So is this factorable by grouping? No. I'm going to erase that. I'm going to say, okay, well, at least I tried, because if it would have done it, if we would have been there, that would have saved us a lot of time. So it's worth it. Worth it to try if you've got this to a cubed root, or to a cubed exponent. All right, now I'm going to go through my possible zeros. My possible zeros are p over q. So p over q, there isn't going to be a q except for just one. Correct? Yeah. So do I really need to do a table for this one?
No.
It's just going to be my factors over 1, my factors over 1, my factors over 1. So if I find all of these factors, that's going to do it for me right there. Now I'm going to write it a little bit differently than I did yesterday. This just came to me and I think it's brilliant. P over Q, every single one of them is going to be plus or minus, correct? If I put the plus or minus right there and then I write out the terms, then as I can check them off as I'm going. You know what I mean? Like if I check them above them, then I'm checking off the positive ones. If I check below, I'm checking off the negative ones. You'll see. All right, so I have plus or minus 1. Plus or minus, does 2 work? Yes. 3, 4, 5, 6, 7, 8. So there's my possible zeros right there. Right? Now I've got to come up with a table that tells me, am I talking in the positive direction or in the negative direction? Oh, first of all, it says possible zeros. So is it factorable? No. How many possible zeros do I have? Well, we did that, but they're there. How many total zeros do I have? 3. Right? The degree of this polynomial is 3. So now we're going to do Descartes' rule of signs. It's function of x in the positive and function of x in the negative to figure out how many positive zeros we have, how many negative zeros we have, and how many imaginary zeros we have. So I'm going to go ahead and count how many sign changes I have. So in the positive direction, is that a sign change?
Yes.
Yes. Is this a sign change?
Yes.
Negative to positive and positive to negative. There's another sign change. So I have 3 positive sign changes. I'm going to go ahead and start my table now. Put the table here. Yesterday I had this big old long explanation. This one's just going to be I have positives, I have negatives, I have i's, and then I have my total number. So I have a total of 1, 2, 3 positives. Now what we learned yesterday is if I have 3 positives, I also know I have a possibility of there only being 1 positive, right? Because we're counting down by 2s. Okay? Could I have 0 positive? No, because when you count consecutive odd integers, you can't get to 0. So I know for sure I have 1, or for sure I have 3 positive zeros. Now the deal with this is they don't necessarily have to be from this list. Okay? Because they could be something that you find with the quadratic formula, which means it could be something that has a root to it, which would be a fraction that doesn't have a, it's irrational, right? And so it's a continuous fraction. So you got to keep that in mind when you think about this stuff. This is just a list to start with. All right. So now I want to go in the negative direction. So first, I must consider, let's move this guy down here. First, I must consider f of x, or h of x, h of negative x. And I'm going to do this first one completely worked out. So if I made x negative and I cubed it, it would become negative. So it would be negative x cubed. If I substituted a negative in for this x, it would be negative 6 times negative x squared. That squared would turn that x positive, so it wouldn't have an effect on the sign of this term. Plus 10x, plus 10 times negative x. That would change the sign. If it's an odd degree, it's going to change the sign. If it's an even degree, it's not going to change the sign. That's basically what it boils down to. And then minus 8. So let's record our sign changes on this one. Is there a sign change? Oh, let's do it here. No. Is there a sign change here? Is there a sign change here? So I know that I have 0 negative roots. So if I need a total of how many? 3, I have 0 imaginary roots in this scenario for a total of 3. If, for instance, I had 1 positive root and 0 negative roots, because I know I don't have any no matter what, how many imaginary would I have? 2 for a total of 3. So this gives us direction. That's what we're doing here. All right, now I'm going to consider my types of roots. We just did that. Behavior of graph. I'm going to draw myself a graph here, and I'm going to start graphing right away, because then it gives me an idea of what I'm doing. So negative 8 tells me it's going to be crossing the y-axis at negative 8. The fact that it's cubed, or an odd function, but a positive odd function means it's going to look something like, we don't exactly know how, but it's going to do that kind of thing. Correct? Doesn't it amaze you how much you already know about this stuff? It's a lot, right? It's a whole lot of stuff. So you should be really proud of yourself for keeping up this far, because that's a lot of stuff. All right. So now I'm going to use synthetic division to go ahead and try and solve this guy. So I know I'm not going to go in the negative direction. I'm just going to start in the positive direction. So I'm going to start with, the easiest thing would be positive 1, correct? First of all, you know what's nice about this? This is what I was talking about, the positive and the negative. I can just cross all these off, right? Based on this. Those are gone. Now I'm going to work on the positives. Do you see what I mean by how I put the positive and the negative, and now I'm eliminating my possible zeros? Mm-hmm. Yeah? All right. Like I've got the positive up above and the negative down below, so all the negatives are out. They're gone. They're done. So now I've got 4 more I can do. So I can only do synthetic division for 4. Okay? So I'm going to start with 1. So here's a positive 1. My coefficients are 1, negative 6, 10, and negative 8. Go ahead and do synthetic division for this. Do you guys want to see, no, I think I'm just going to keep it this way. On Monday, I'll show you a table that you don't have to write quite as much, but I think for today, so we're just solidifying the whole thing, I think we'll just leave it like this. All right, so I bring down the 1. 1 times 1 is 1. negative 5, negative 5, 5, 5. Is this going to work?
No.
No. All right, let's go to the next one. I should say 1 doesn't work. It's done. Let's try 2. So I'm going to go to 2. You want me to change the color as I go? Okay. Let's try a 2. So 1, negative 6. Would it bug you guys if I just went straight to this? Bring down the 1.
No.
Sorry. Bring down the 1. 2 times 1 is 2. 2 and negative 6 make negative 4. 2 times negative 4 is negative 8. 10 and negative 8 make positive 2. 2 times 2 is 4. Negative 8 and 4 make negative 4. So 2 didn't work. Next, I'm just going to go back and forth from black and blue. Now I'm going to try 4. Bring down the 1. 1 times 4 is 4. We should probably cross this off so I don't get all mixed up. Done with this and this. Right? Does that help? Done with this? Alright, so I bring down the 1. 4 times 1 is 4. Negative 6 and 4 is negative 2. 4 times negative 2 is negative 8. Negative 8 and 10 make 2. 4 times 2 is 8. Negative 8 and 8 make 0. Bingo. There it is right there. Alright, what do I do with this? Well, this is a trinomial, so I'm going to see if I can factor it. Is x squared minus 2x plus 2 factorable? Is it? What are the only two factors of 2? 2 and 1. Is that going to get me to negative 2x? It's not factorable. Right? Now where would you go? What? Some of you would use quadratic formula. I'm going to use completing the square because you know how to use quadratic formula, so I'm going to complete the square because I think it's easier. Alright, so I'm going to say x squared minus 2x. I need to complete the square, right? I'm going to add something, and I'm going to subtract something, and then I have that plus 2 equals 0. What would I add and subtract?
1.
Because 2 cut in half is 1, and 1 squared is 1. There is my perfect square right there. X, it's going to be a negative because that's negative. X minus 1 squared equals negative 1 plus 2 is 1. Sorry, I'm skipping a step. Plus 1 equals 0. If I was doing that in my head, I would be putting it over on the other side right away. Everybody follow me so far here? Alright, so now it's x minus 1 squared equals negative 1. This is going to be i's, right? Take the square root of both sides, and I get x minus 1 equals plus and minus I, which is going to be x equals 1 plus and minus I. So my roots are 4, 1 plus I, and 1 minus I. Doesn't that look a lot like what we just did in the very beginning? Alright, let's start from the beginning. Let you guys copy that down. Okay, I almost forgot that we needed to consider all of these scenarios. Right? If I put in 1, what am I going to get? 8, negative 8 plus 5. Negative 3. So if I put in 1, I would get negative 3. So something like that. If I put in 2, I would have gotten negative 4. 2, negative 4, something like that. That looks like a Imaginary root right there, right? Then if I put in 4, I got 0. So 4, I got 0. So this went like this. That's what that graph did. Alright, I'll let you guys continue copying this down. Alright, let's do the next one. So, the first thing, I did graph.
Oh.
I went back and graphed it. Okay, so the next thing we're going to do is, what would be the first thing I would check? Is it factorable? So I'm going to put it in a table and see if it's factorable. X cubed negative 7x squared, 25x negative 175. This would be x squared. X squared times x is x cubed. X squared times negative 7 is negative 7x squared. What do these two have in common? 25. 25 times x is 25, and 25 times negative 7 is negative 175. This guy is factorable by grouping. X minus 7, x squared plus 25. Now what? Well, we don't have anything for the sum of two squares, only cubes. We're going to set them equal to 0. So x minus 7 equals 0, and x squared plus 25 equals 0. X equals 7. X squared equals negative 25. Take the square root of both sides. And I have x equals plus or minus 5i. 3 roots. Questions?
Oh,
No?
wait.
Yes.
So why can't you do x plus 5 x plus 5?
Because that's not the difference of two squares.
I mean, x plus 5 x plus 5.
It doesn't work that way. X plus 5, now here's where it kind of gets a little bit crazy. The difference of two squares is where you've got, you can break them up and do plus and a minus. But this turns out to be this one squared, this one squared, and then both of them multiplied by each other times 2. Alright? That's what that would look like. So this does nothing for me. Right? Now if it was the sum of 2 cubes, it would look like this. X and 5 and x squared and 25 and 5x. Do you see the comparison? Oops, that would be negative. Do you see the comparison of the two that I just did? You're taking squares and the squares, the squares and the squares. Only this one it stays 5x, and this one the 5x is multiplied by 2. Because if you were to FOIL this, x plus 5 and x plus 5, wouldn't you get 5x and 5x, which makes 10x? Are you seeing it? A little bit? I'm going to do more of that on Monday anyway. Okay, we're going to be doing a lot more factoring review on Monday. All right. But I'm glad you're looking for those squares and you're recognizing them. That's good. Okay, so make sure you've got that written down, and then we'll go on to the next one. Sit down. So, some of you are asking me for the solid answer. We've got your roots are, we'll put them like this, 7, 5i, and negative 5i. 1 real, 2 imaginary. 2, 1. Do you guys want to try this one on your own? One more and then try it on your own? All right, is it factorable? I'm going to do that real quick. Let's see, 2x cubed, negative 17x squared, 90x, negative 41. I'm going to say nothing times anything is going to be negative 41, right? Correct? Like, it's not going to happen. Aww, now I got to do work. Okay. All right, so here's my p. And here's, actually, wasn't I doing the red Q? Got to be consistent, right? Oh, this one's not too bad. So P is either going to be plus or minus 1
Plus 41.
or plus or minus 41, and Q is plus or minus 1, plus or minus 2. So my table, my P over Q table, right, would be a 2 by 2?
Yeah.
Correct? It's not bad. Alright, so my P's are here, so plus or minus 1 and plus or minus, I'll make it blue so it's pretty, plus or minus 1, plus or minus 41, and my Q's are plus or minus 1, plus or minus 2. So this would be plus or minus 1, plus or minus 41, plus or minus 1/2, plus or minus 41 over 2, and let's just all be honest, if it was that, you all would have given up by then anyways, right?
Yeah.
Alright, we'll just call it what it is. Not that I'm encouraging that, I'm just saying what it is. Okay. Just stating the facts. So, my possible zeros are plus or minus 1, 1/2, 41 halves, and 41. Alright, we've got 7 minutes to finish this up. Okay, so is it factorable? No. Possible zeros, we got those. Total zeros, 3. Now we got to do the law of signs. So in the positive direction, I've got a sign change there, and I've got a sign change here, and I've got a sign change here. So I have plus, minus, I, and total. My total positives would be 3 or 1. Negatives, I'm going to do this one a little bit faster, okay? Remember what I said about the whole negative aspect? If it's odd, it's going to change the sign. If it's even, it's not. So Q of negative x, Q of negative x equals, that's odd, so that's going to change that side. This one's even, so it's not going to change the sign. This one's odd, so it's going to change that sign. And this one doesn't have an x, so it doesn't change the sign. So, no sign change, no sign change, no sign change. It's a good thing, right?
Yeah.
No negatives, no negatives. So this makes a total of 3, so there's none there. I would have a possibility of 1 positive and 2 imaginary. Are we good? So now we're going to start our synthetic division. So I might as well start with, we'll go green. Alright, so oh, here's our graph.
Yeah.
You don't want green?
Oh, green. Oh, I like green.
Oh.
I like green.
Negative 41, that's way down here. I'm just trying to change up my colors. Okay. So we'll start with positive direction. I'm going to start with 1. Yeah?
Yeah.
Let's do 1. My coefficients are 2, negative 17, positive 90, negative 41. Bring down the 2. 1 times 2 is 2. That's negative 15, negative 15. What is that? 75?
Yeah.
Is this going to work? What's 75 minus 41? 34?
Yeah.
Is that right?
Yeah.
So 1, 34. So right about here. What do you want to try next? So 1 doesn't work. We know none of these work, right? None in the negative direction. So we're going to try what? Let's try 1/2. It might not be that bad. I said I was going to change colors. Alright, so this didn't work. This didn't work. And now we're going to try 1/2. So I'm going to bring down the 2. 1/2 times 2 is 1, negative 16, and 1 is, I'm sorry, negative 17 and 1 is negative 16. I'm telling you what it is as I'm asking. Half of negative 16 is negative 8. Negative 8 and 90 make 82. What's half of 82? 41. Bingo. There it is there. You will, on the test, have one of these that's a fraction. You've got to be able to do that. Okay? Was that really that bad?
No.
You can tell when the fractions aren't going to work out. You know what I mean? Like, it just gets crazy and you're just like, yeah, I'm not doing this anymore. All right. So there's a 0 of ours right there. So now I have 2x squared minus 16x plus 82 equals 0. How could I simplify this before I even start? GCS. Take out a 2 and I have x squared minus 8x plus 41 equals 0. I'm guessing this is not factorable. I could complete the square. Would you rather me complete the square, or would you rather me use quadratic formula? I think complete the square would be much easier here. So here it is. X squared minus 8x plus something minus something plus 41 equals 0. What would complete the square? 8 cut in half is 4. 4 squared is 16. There's your square right there, which is x minus 4 squared. What's negative 16 and positive 41? $35, 34? No, 35. You're right. 35. So positive 35 equals, nope, 25. 25. You know how you do that? You say, okay, do your answer, and then you go, well, if I took 35 and added 16, would I get 41? No, I'm too high. So 25 plus 16 is 41. So this is going to actually turn out pretty well for us. It's going to become x minus 4 squared equals negative 25. Take the square root of both sides, and you get x minus 4 equals plus or minus 5i. So x equals 4 plus or minus 5i. So my zeros are 1/2, 4 plus 5i, 4 minus 5i. And I've done 3 of your homework problems for you. Okay? I think one of your homework problems is to the 4th power. Once you get down to the 3rd, you should try and factor by grouping first, right, before you move on. Make sense?
Yeah.
All right, good job, guys.